Okay, in this video, I want to talk about what the average velocity and the instantaneous velocity mean graphically. So we understood from the previous videos that if I have p, which tells me my position, then the average velocity over a time interval a to b is given by this formula, p of b minus p of a over b minus a. And the instantaneous velocity is if I take the limit as that interval goes to 0 around t, so the limit of p of t plus h minus p of t over h. So I want to first start with this, the average velocity. So graphically, I want to look at what this means. So if I have my position, so this is y is p of t, and this, the x-axis here is t, it's the t-axis. So I want to look at what this formula is saying according to this graph, right? So let's look at the numerator first. So p of b minus p of a. If I look at p of b, that's the y coordinate here, right? So this is this y coordinate is p of b. And if I look at p of a, that's the y coordinate here, right? So if I look at the difference between them, that's this vertical distance. So it's sort of this here down to here. This vertical distance is p of b minus p of a. So you can think of that, yeah, I mean, it's the difference in the y values, right? It's the y value at the end minus the y value in the beginning. And what is b minus a? So b minus a is the length of this interval. So it's the length of this horizontal interval on the t-axis, right? And so if I take the ratio of these two, I'm taking a change in the y value, and I'm dividing by a change in the x value, so p, or the t value, so p of b minus p of a over b minus a. This is the change in y over the horizontal change. And so this, you can think of this as rise over run, right? So this is rise over run. So this is the slope, right? This is telling me a slope. And in particular, it's telling me the slope of the line between these 2 points, right? That's how I figure out the slope of a line between 2 points. I take the change in y value, the rise, over the change in the x value or the t value, the run. So this is giving me the slope of this line. So this average velocity is the slope of this line. Okay, and so that's how you should think of average velocity. If I have my function, which is telling me my position at time t, then the average velocity between 2 points is, well, I can plot the 2 points on the graph, I can take the line between them, and it's the slope of this line. So let's think about instantaneous velocity. I'm going to bring up a calculator here. So we have a similar thing going on here. I have, this is my t value. I'm going to say t, or I think it's called a here. So a here is negative 1.5. And I want to know what is the instantaneous velocity at a equals negative 1.5. So I can take progressively smaller average velocity. So right now, the average velocity, so this, what is this graphing right now? It's graphing the average velocity between a is negative 1.5 and a plus h. So I'm going to be able to slide h here. So the average velocity, as we said from before, is that's the slope of this line, right? And to get the instantaneous velocity at this point, a equals negative 1.5, I want to take this interval to be smaller and smaller. So I want to take h to be smaller and smaller. So here, like, let's see if I make h 1/2, 0.5, then it's getting closer and closer to, then it's getting closer to here. And so the slope of this line is the average velocity over this time interval of length 1/2. If I make it 0.1, okay, the slope of this line is the average velocity over the interval of length 0.1. If I make this really small, 0.001, then the average velocity over that time is the slope of this line between these 2 points. And if I zoom in here, it's looking like this slope is approaching, the tangent line to this curve. And that's actually how we define the tangent line. So the average velocity over a time interval is the slope of this secant line, so the slope between these 2 points. The instantaneous velocity, when I take this, this interval down to 0, so the interval between here and here, when I bring these 2 points closer and closer together, so I'm doing this, I'm bringing these points closer and closer together, each secant line like this gives me, the slope of it gives me the average velocity over that time interval. And as I take this limit, so as I take these points, the limit of them getting closer and closer together, then the limiting value is going to be the tangent line here. So this is going to be the slope of the tangent line to this curve is going to be the instantaneous velocity at time t. So this is graphically what average velocity and instantaneous velocity means. It's the slope of the line, either secant to the curve or tangent to the curve, depending on if we're talking about average velocity over a time interval or instantaneous velocity at a fixed time.